And obviously I'm not standing in front of everything. Okay, so you're all being recorded this time around. Your test opens today. It did at 8 o'clock. And so it is same format as the rest. There's a little bit more short answer on this one than in the past. I kind of want to get you being able to explain things and prep you a little bit for the final exam, which will also be short answer for those who have elected to take the final exam. I did see nearly everyone signed up, so that's good. And some of you indicated already to me that you weren't going to take it, which is also fine. As a reminder, your exam today will close tomorrow by midnight, so 11:59 p.m. on Tuesday. So make sure that you take it. You have today and tomorrow, all day today and all day tomorrow to take it. So take it when you're ready to do that. Those of you who are taking the final exam, your final exam opens on Monday. We're technically scheduled, I think, for a Thursday final based on the calendar for the school, but like I've done in the past, I'll just open it for a few days. So it'll open on Wednesday, it'll close on Friday, and by midnight again. So you'll have all day Wednesday, all day Thursday, and all day Friday to take your final exam. When you go into Canvas to do that, it will be under a module on the homepage, under a module that says final exams, and your name will appear as one of the quizzes available. You should only see your quiz. I think that's how it works. So you should only have one quiz available to you, and then you should take that exam. I do want to point out on your exam for today, and I'm going to share, I'm going to pull this up, I'm just going to put it in student view before I share it. So I do want to point out, let me share our Canvas screen. Okay, so this is obviously our Canvas page. On your Canvas page, I'm just going to close this. Under the exam for today, so this is the exam for today, right underneath is the course evaluation. So I decided I do want to do a course evaluation for this class. I don't need to do them necessarily anymore. I always do them for my own growth. But because this was taught online and I had not done that before, this would be really helpful. So I would appreciate if you filled out this course evaluation. You'll see that I don't have it. It'll be open until the 18th. It's a Qualtrics survey. It's a typical course evaluation, but then there's some kind of just questions specific to the class. And really, since I've never taught this class online, I would love some feedback. So general feedback would be great. It is completely anonymous. I do not get these results until after grades are submitted, that sort of standard student evaluation process. But it would really be great if you would just take 10 minutes or so to complete that sometime this week. And right after the assessment makes some sense. And I will send a reminder email about that as well. So, like I mentioned, you should see it'll pop up right as the first thing for your final exam. I'll put it above the general course information, and I believe you will only see access to your own personal exam. I don't think you'll see everybody's name that you have to find your name in. I think you'll just see yours. All right. Any questions on today's assessment or the final exam? All right. So we only had one more topic to talk about today, and it is a relatively straightforward topic. It's sort of fun. But then after we're done with that topic, all of optics is complete, and I can hang around to answer questions if you looked at some of the extra practice, that sort of a thing. So our last topic is colored objects under colored lights. So we talked about colored objects, and we said that a colored object is defined as being that color because of the light it reflects. So a yellow object is yellow because it absorbs the blue light that we present it normally in white light, which is what we normally view the world in. It absorbs the blue. and it reflects the red and the green. And when red and green, excuse me, when red and green are hitting the eye at the same spot, the same location, we perceive that as yellow. So the question then comes, well, what if I don't present it with white light? What if I present it with other color light? We follow the same process of deductive reasoning when we do that. So I am going to share the screen with you. I'm going to try it this way since it was just a single topic rather than up on the board. You'll just have to listen in to my voice versus not, but we're going to get the camera situated first. All right, so let me share this with you. A bit of technology today. All right, so you should see the table, the desk on my, or the paper on my desk. So a little more space, I think, would help. Oops. Oh, heavens, heavens, heavens. If you get nauseous by things moving, close your eyes, our usual rule of thumb. All right. So if I have a yellow object, we know that under normal conditions, we have white light shining down. And that white light is blue, red, and green. So blue, red, and green light are always shining down on our normal environment. That's our assumption. And so like we've already talked, if I have a yellow object, the red light reflects, the green light reflects. We interpret this as yellow. And the blue light is absorbed in the object. So we've already talked about this. Well, what happens if I shine a different color light on this yellow object? So instead of presenting this yellow object with blue, red, and green, white light, what if I only present it with red light? So I put a filter over a white light, a red filter, it only allows red light to get through, and I only present this yellow object with red light. What color would it look? Well, normally it reflects, it has the ability to reflect red and green. That's the molecular makeup of the object itself. But I'm not presenting it with green light, so it's not going to reflect green light. I'm not presenting it with blue light, so it's not going to absorb the blue light. I'm only presenting it with red light, which it's capable of reflecting. And indeed, this red object, or this yellow object, excuse me, now appears red because I'm only presenting it with that red light, and red indeed reflects. What if I presented this yellow object with cyan light? Well, cyan light is blue and green. A normal yellow object has the molecular makeup to absorb the blue, but it will reflect the green. And so now this yellow object would appear green. So when we're looking at colored objects under colored lights, that's how we need to go through the deductive reasoning process to analyze what is it I will see, or if I see an object of a specific color, what are the possibilities of lights shining on it? So in either order, recognizing what under the actual object's ability to reflect and absorb light, what does it do? And that will be the color presented under white light. So a yellow object has the ability to reflect red and green, and it absorbs blue. So under white light, it's indeed yellow. Then keeping that in mind and examining, well, what will it do with the light that's presented to it? A red light it'll reflect it, so the object would appear red. A cyan light, well, it'll reflect the green, but it'll absorb the blue, so the object will appear green. So let's just look at that. Let's see that in action. So I am going to remove this. All right. So I have a magenta filter. So I can put this magenta filter over this light, and you should just see kind of the world of magenta. So I'm going to put 2 strips of paper under this magenta filter. So I have paper A and paper B. Both of these sheets of paper, I'll put them in a brighter spot. Both of these sheets of paper, actually this might help avoid the reflection that's on my desk. Let's do this. There, that might help a little bit. Both of these pieces of paper look blue. I gotta figure out which way to put them so they're in the middle. Both of these pieces of paper look blue, but in reality, one of them is cyan and the other one is blue. So why is it that the cyan looks just as blue as the blue? Well, the cyan normally will reflect blue and green. Magenta is allowing which two colors to come through. It's allowing blue to get through and red to get through. So my cyan, which is this one, my cyan paper doesn't have green to do anything with, so doesn't care. It takes the red light that's getting through and absorbs it, and it reflects the blue light. My blue paper, well, it takes the red light that's getting through it and absorbs it, and it reflects the blue light. So in both these cases, only blue light is being reflected, and they appear to be identical. What if I have a cyan filter? So I have a cyan filter. Well, the kind of world kind of looks cyan. And I put a magenta strip underneath a cyan filter. What color, so make a prediction in your head, what color should a magenta strip look under a cyan filter? So thinking about what magenta does under normal white light, what light is being presented to the magenta paper, and therefore what light will it be reflected back into my eye? So there's my magenta paper. What color does it look? Well, it looks very similar, almost identical, to the blue sheet of paper. So the magenta color, of course, reflects red and blue. I'm presenting it with red and green, with blue and green with the cyan filter. Really, the green gets absorbed, blue is reflected, just like it would be if I had the blue sheet of paper. All right, so that's colored objects under colored lights. I'm going to do a little test with you first. And this is, so get out a sheet of paper so you can sort of predict for yourself. I got to get the whole, let me put this so I can get the whole sheet of paper on here. All right, so here's our sheet of paper. Oh, this is nuts. My keyboard. What I want you to do is say which colors you will see. So when I put two different filters over the sheet of paper. So I have a white strip. Then we'll do the primary colors first. So we have red next to white, then green, then blue. So here's our red, green, and blue strips. Then I'm going to put cyan, magenta, and yellow. Okay, so A, B, C, D, E, F, and G. All right, so here's your, and then I'm going to add black. Right, I know that's highly reflective right now, so let's try to do this differently. There we go. Okay, so we have white, red, green, blue, cyan, magenta, and yellow, and black. What colors will you see if I put a yellow light over the camera? So what colors will you see if I put a yellow light over the camera? So someone type for me in the chat, once you figure it out for yourself. It's a little bit of typing, but type through the chat what you think you will see. And then if you like what somebody wrote, put your thumbs up. If you have something different, Write a different series, write what you think you will see with a yellow filter. So yellow light is going to be presented to these colors. And you can just write them in order A, B, C, D, E, F, G. Black is just for a reference. You don't have to. Black will look black because it absorbs everything. All right, so we have our first prediction. Let's see if you agree with Ian after you write your prediction, put a thumbs up. If you have a different, you can just put down your difference if you have something that you think is different. I'll just give you all a few minutes. Try to make your own predictions first and then compare them. We had a vote, then we took one away. So many people are in. Once we get at least half, well. All right, there's 12 of you in. So far I have 5 plus Ian, that makes 6. So we'll see if we get a couple more people or if we have a difference of opinion. All right, we're up to 6. So let's test it and then I can see who all 6 of you are and I'm going to ask you to unmute and we will see if you can explain one of the colors. All right, so we'll put a yellow filter in over the thing. Ugh, this yellow does not work like my other one did. What? Let's see if I can do it this way. Oh, this makes me so sad. I just tested this. It's too bright. Let's turn the camera off. Well, let's go over it, shall we? Magenta is not working. Okay, so white appears yellow because I'm just going to walk us through it. White appears yellow because it reflects all 3 colors. I tested this one too. I wrote it down. B was red, and red still appears red. Why? Well, the yellow light lets red light through, and it reflects red light. C appears green. Same reasoning. So green usually reflects green light, and yellow lets green through, so it reflects that green light, absorbs the red light. Blue is black. Blue absorbs red and green light, and yellow is going through with red and green is going through the yellow filter. And the secondary colors did not work as well. So cyan isn't totally off from green. It's not too bad. Magenta should have definitely been red. So F was magenta. You all who put it would definitely be red. And when I looked at it earlier today, it worked splendidly, but it's not working with this light camera. Yellow will be yellow and black will be black. All right, nice job. So the answers are indeed correct. I'm skeptical. I used my computer camera, and I'm using a different camera. So let's see what happens if we put green over our filter and see if we can get the coloring. This is a little bit better from our coloring perspective. So I now have, although yellow isn't working and it worked great earlier today. So I green over my camera and we can see that red is black, blue is black, and magenta is black. And those are the ones that we would expect to be black because those three colors absorb the green. And black, of course, is black. My green color is indeed green, and my cyan not too off of the green. So there's my cyan on top of the green light. Yellow, however, should also just appear green, and it does not appear green. It looks yellow under this particular filter. But if I put it under, let's try this. I'll try this because this is the way I'm looking at it. If I go here and we put our camera over, let's see if I get too much white light, we can now see that the color of the surround, like my wall, and the color of the strip both kind of appear green in this case. So that lighting works a little bit better when I get rid of some of the white light being reflected in the camera. All right. So colored objects under colored lights, that's pretty much it. Any questions on that idea? Camera out of the way. And I'm going to have one more thing to show you and then I'll field any questions. So questions on colored objects under colored lights. All right. So that's the idea of dissociating the color of the object from the light first and then looking at the light being presented to you. So the last thing I want to show you, which I think is kind of cool, is we've been talking about additive color mixing, colored objects, and subtractive color mixing. Well, this year, my daughter, I've mentioned in a test, is an atmospheric science major at the University of North Dakota. And part of what those students do, some of those students are meteorology focused students, so they want to be meteorologists and broadcasting. She's not necessarily in that category, but she does do broadcasting for their weather station. And the other day, and this is actually a September broadcast, she told me to watch her broadcast. I do anyway, of course, she's my daughter, so I watch every broadcast of hers. And I was fascinated with what I saw. So at UND, instead of using a green screen, they use a blue screen. And the reason for that is so that they can wear green. It's North Dakota after all. Go Fighting Hawks, right? Their colors are green and white and pink actually, but mostly green and white. So they want their broadcasters to be able to wear their UND colors. And so they use a blue screen instead of a green screen. Now, the way that a blue screen or green screen works in film production is that it takes, you stand in front of a green screen or blue screen, and in post-production, mostly, although it can be done in live production, which happens to be the case in their studio, we'll pull out a very narrow band of color, the green or the blue, depending on what the screen is, and replace that with whatever image they want in the background. So my daughter wore a magenta dress one day to broadcast in. And this particular color of dress resulted in, on the blue screen, it appearing red. So here we have a situation where the dress she wore was this nice magenta, and we know that magenta reflects blue and red. But this particular blue used in the coloring was the exact match of the blue frequency that they pull out of the video production in order to put the background in that they want to use. And so her dress appeared to be red, which I thought was a great example of additive color mixing to share with you. So this color and this color are clearly not the same. But I told her that both looked fabulous. So a little bit of fun technology that when the coloring is just right, you can get a substantial change in the images that the viewer sees. Okay, that is it. We are done with this topic. So your assessment has 12 concepts on them. Of course, they're listed for you. We've gone through all of them, and you'll have, of course, 2 questions per concept. So the test is 24 questions long, and we're good. That's it. So I will stick around if there's any questions about some of that material you want to review before you take the final, or sorry, before you take today's assessment. But other than that, you are good to go. So thanks for a great semester. Please reach out to me if you have any questions between now and when you take your final. We certainly can set up a time and all of that, and good luck with your week, because I know it's a busy week. So, but I'll hang out in case people have questions.